Hello everyone, this is Anita. Welcome to the ML video lecture series. So in this video, we will see post-pruning and pre-pruning implementation in Python. So let's get started. So let me open my Jupyter notebook window. So here I have already written the code. So we will see how the code is written with explanation. So for creating any model, the first thing is we need to import the library. So here you can see I have imported all the libraries. So first library is the pandas library, that is import pandas as a PD. The second one is for visualization purpose, that matplotlib.pyplot as a PLT. The next one is I want to use the iris dataset for this. So for that, in sklearn.dataset this iris is there. So I am just from sklearn.dataset I am importing iris dataset. So with the help of this load underscore iris, after that I am importing Seaborn libraries. Then from sklearn.tree I am importing the decision tree classifier. Then uh, for creating model I want to do the trend test split, so that I am importing from the sklearn.model selection, and I want to see the accuracy score, so that I am importing from sklearn.metrics. So this first I am importing all the libraries which are required for implementation purpose. The second thing is I want to load the iris dataset. So here you can see that. So let me run this command. So now the second one is, here you can see load. I want to load, so I am using load underscore iris method, and which is here iris, all the data iris data is stored into this iris object. And after that, in iris.data all the independent features are there, or we can say the attributes are there. And that y is my target attribute or the dependent attribute. So in iris data set, this is the a common data set that everyone is using. So in the iris data set we are having the here you can see in the description we will understand the data. So in iris data set, the sepal length, sepal width, petal length, petal width, these four attribute are there, and based on this they are predicting the class of the flower. So that flower may be setosa, versicolor and virginica. So these are the categories. So this is one of the most popular classification problem. And here you can see in this data set we are having the 150 instances. So 50 in each category, that means 50 for setosa, 50 for versicolor and 50 for virginica. So this is how the data set is there. So I am just loading into X all the independent feature, and in Y the dependent feature, that means separating the input and the output values here. So you can see with the help of that iris.key you are getting the key value pair. So in data, target name, description, feature names, so we are getting all this. So you can see these are the output of the iris.description. Now I want to split the data set into training and testing. So here I am using the 30-70%. So 70 for training purpose, 70% and 30% for the testing. So for that what I am writing here, x train comma x test, y train comma y test is equal to train test split x comma y comma test size is equal to 0.3. So 30-70 I am using, so that's why I have mentioned here test size. So suppose you want to use 80-20, so you just mention 0.2. So here I am splitting my data into training and testing. After that, first we will see the normal decision tree, and after that we will be applying the pruning technique as pre-pruning and post-pruning. So this is the only that decision tree classifier I am calling. So here you can see this is a method, and the CLF is the object of this decision tree. After creating the decision tree I am using fit method for training, and for that fit method I am passing my data, training data, as x train and y train. That means here we are performing the training. After running this, so let me run this command first, that splitting, then this one. after that you can see I want to predict on the training data. So I'm just using ytrain predict is equal to clf dot predict method. So on xtrain I want to predict the ytrain, and for that I want to check the accuracy. So for accuracy score I am using training and prediction score. So you can see, okay, so here we have run this command. After that I want to predict on the testing. So you can see clf dot predict x test and accuracy score y test and y test prediction. So here I am getting the testing accuracy. So after that I am just printing that training accuracy and testing accuracy. So you can see the training accuracy is 100% and on testing accuracy 95%. That means with the help of this you can say that without any pruning technique, our decision tree generated, and that tree is overfitted on the training data set. So this is the interpretation we have derived from this. Now, after this, we are applying the pre-pruning technique. So, as in the previous lecture, we have seen pre-pruning means while generating the decision tree, we are applying some hyperparameters, or we are using some hyperparameters. So, hyperparameter is nothing but the best parameter. So here you can see again I am just calling that decision tree classifier, and here I am using maximum depth is equal to 5, and after generating I am train that model. So fit method with the help of fit. So let me run this. So here our decision tree is generated with maximum depth equal to 5. After that I want to apply the second hyperparameter as minimum sample leaf is equal to 10. So as I have already told you, if we are mentioning that key minimum sample leaf equal to 10, so the leaf here by setting this minimum number of sample required at the leaf node, we can prevent the tree from creating the overfitting by creating the branches with very few samples. So you can see what we have mentioned here. We have mentioned size as a 10. So minimum sample leaf equal to 10. So here this hyperparameter value we have used. This means that the leaf node or the terminal node in the decision tree must have at least 10 sample in order for it to be created. If certain split result in the leaf node with only 5 sample, so split will not be allowed because value condition is not matched. So this is the second hyperparameter, and in third hyperparameter you can see we have used the minimum sample split as the value 20. So if this is not match, then again it will not allow to split that branch. Okay, so this is the next. Now after this what I am using, so these are the hyperparameter that I have used. Now from this what I want to like draw the decision tree, or like with the help of this I want to see key which parameters are the best parameters. So how to choose this? So with the help of grid search CV we will be finding the best combination or the best hyperparameters. So that's why I am importing here grid search CV from sklearn.model selection. So let me run this. After running you can see after this what we have written here, we have defined the uh, parameter grid. So in this parameter grid is nothing but it is a dictionary with the parameter name as the key. You can see the criteria, so it is a key, and value of this is a Gini and entropy, maximum depth. So you can take from this 2 3 4 5. Minimum sample leaf either you take 10 20 30. Minimum sample split either you split with 20 30 40. So these are the parameters we have given. So on this parameter it is applying the grid search CV with you can see here with some cross validation value as 5. So here you can see I am just creating the instance of that grid search CV by applying the tree and parameter grid and cross validation value is equal to 5. So here we will be using the k-fold cross validation. So this grid search CV applied on this parameter, so it is like it is making the combination of all these value and it is finding the best parameters. So here after doing this I am just fitting my grid search CV to the data and finding the best parameter. So with the help of this best parameter method which is there in the grid search, we will be printing. So you can see these are the best hyperparameter having they are saying ki you use the Gini as a criteria for building decision tree. Maximum depth you can use as a 3, minimum sample leaf you can use as a 20, and minimum sample split you can use as a 20. So this is what the best hyperparameter they are giving. So now on this best hyperparameter I am creating the decision tree and I am fitting my data. So let me run this. And after this let me draw that decision tree with the help of this tree dot plot tree. That decision tree feature names I am giving here: sepal length, sepal width, petal length, petal width, and field equal to true. So with the help of this we are getting such a type of tree. So here you can see having maximum depth equal to 2. So you can see this is at level 0, this is at level 1, and this is at level 2. So you can see Gini parameter they have used, and Gini is having the like a range from 0 to 0.5. So you can see 0 is there and here 0.5. So on the left hand side Gini equal to 0, that means it is a pure split, and on the right hand side some value is there. Gini is having 0.5, that means it is not pure split, it is impure. So we are dividing it again. So here you can see at first we have used petal length feature, and for this condition we are checking if it is true. The left hand side we will be going, and if it is not, on right hand side we will be going. Again on right hand side it will be checking for petal length, and you can see here 0, 50, 50. That means here 50 is for the versicolor and 50 for the virginica. So this is a count or it specifies the count having the this much it is a count actually of the versicolor and for the virginica. So again it is splitted based on the criteria up to 2. So now at the end you can see majority of the class values are belonging to the versicolor, and on the right hand side you can see majority of the value are belonging to the virginica. So this is how we will be using the pre-pruning technique to avoid that overfitting. And now we will be using the post pruning. So again I am using that decision tree classifier, and here as in the lecture I have told you I am using this cost complexity pruning path method which is there in the sklearn. So that technique I am using, and for that I am passing the input and output, and so it is giving me this path is giving me the values, that best CCP alpha values and the impurities values. So you can see after printing that alpha value we are getting these many values. Okay, so after that I am using the same technique, that is this printing that alpha value. So this param grid, it is a dictionary I am using, so that alpha value I am applying to this CCP alpha, and on that I am using the grid search CV here with the cross validation equal to 5. So again it is like trial and error, it is finding the best combination, and here you can see print the best alpha. So it is giving me 0.00662 value as a best alpha value, and on that value I am training here my decision tree, and after printing you can see the tree is generated. So you can see this is what after the post pruning technique. And now here I want to print the accuracy score. So you can see the accuracy score is the 94%. So this is all about the pre-pruning and post-pruning technique. So I hope you like this video. Thank you.